Okay, so yeah, when we have a prism, and we talked about that earlier, what shape that is, you can have triangular prism, you can have a trapezoidal prism. There's all sorts of, those are the two easiest for me to draw anyway. You know, you can have different shaped prisms, but that's, you know, the basics of them. Well, here's the thing, and this kind of goes along with, and we're just going to do the volumes for these. We could do the surface area, but they usually just ask for volumes on these. The volume, all right, so if we think about, so we took, you know, on the cylinder for the volume, we took the pi r squared and multiply it by the height. Well, to do the volume here, it's the very same concept. I'm going to take whatever area is the top, or the base, it doesn't matter. Do a very good job. But whatever that area is on top, which in this case would be a triangle, I'm going to multiply it by the height. Now the problem is, this area is 1/2 base times height. What about this one? It's not 1/2 base times height, is it? The area of this one is the area of a trapezoid. And so the formula here would be the area of a trapezoid times the height, right? So here's the way they denote it then. What they're going to call it is, you're going to take big B times H, where big B is the area of the base, top, or they're the same. The base and the top are congruent. So you're going to take whatever that area of the top or the base is and multiply it by the height. That's going to give you the volume. Same concept as the cylinder, if you would. Okay? All right, so let's just do one of each of those just to get the idea. All right, so let's put some numbers on this one. Okay, so let's say this prism has a height of 6 centimeters, and it's kind of hard to draw. Let me just draw the top here separate. So that the top or the base is look like a 5 centimeter and a 3 centimeter maybe height. So yeah, so for this one you would need a base and a height for the triangle. So what's the volume? Well, it's big B times H. It's a prism. But big B, how we get big B? Well, big B, I'm talking area of a triangle. Right? So that would be 1/2 times the base of the triangle times the height of the triangle, which in this particular case, the base and the height of the triangle, that's why I drew it out here, it's a 5 centimeter base, and then the height is 3 centimeters with that. So that's what, half of 15, 7.5? Is everybody okay on that? That would be the big B calculation in this case. That's what I would put in for big B here. For the volume. Now then I would take that times the height of, it's the height of the prism, which is 6 centimeters. I meant centimeters. If it was 6 meters, that would be pretty tall. Prism. So is that all right? 7.5 times your 6, was that 45? Is that 45? Is that right? Yeah. And again, we're talking volume, so that's cubic centimeters. Now, is that all right? Now, if I have this trapezoidal prism, And let's say its height is 6 centimeters. And, all right, so its base is 5 centimeters, but I'm going to need a couple other things for that trapezoid top or base. I'm going to need this for little b, right? So let's call that 2 centimeters, and then make that height again 3 centimeters. We're going to need a couple other things. So again, the volume, since it's a prism, it's b times h. But in this case, b, we're talking the trapezoid, right? Area of a trapezoid. Which that's a different formula. Area of a trapezoid, one of the ones you should know, is 1/2 big B plus little b times h. So you see this big B formula is different depending on the size of your top or bottom, right? So it could be trapezoid, it could be a square, it could be a triangle, really it could be anything. All right, so this one comes out to be 1/2, big B is 5, the little b is 2, and then the height is, the trapezoid is 3. So it's half of 7 times 3, half of 21, which is 10.5. And so that's the big B here. So it's 10.5 times the height, which is 6 of the prism. Is that 63? All right, 10.5 times 6. Now, good news on pyramids is it's very similar to the prism. All right, we usually think, like I said, we usually think of the square-based pyramids in Egypt, Las Vegas. They try to copy things. Well, yeah, it turns out though, the volume of a pyramid, kind of like the cone, you got your prism is big B times h, well the pyramid is 1/3 big B times h. Again, where big B is the area of the base. But again, big B formula could change because, yeah, if I've got a square here, let's say this one is, let's make it 50 feet by 50 feet square base. And then the height, let's make the height 80 feet is the height, okay? Well, the volume of that thing is going to be 1/3 times, all right, so big B in this case, you got a square. So area of a square, side squared, squared. So that's 2,500. That's big B. Times the height, which is 80. So that, I'll let you multiply that out, but that's going to give you your volume. 1/3 times 2,500 times 80. Now, the thing is, if you've got a triangular base, say that just cuts across there, well, to get the big B there, for that one, you'd have to use 1/2 base times height, like we did on the pyramid, prism. So, anyway. Got one more, then I'll be done. The other one is the sphere, and it's the three-dimensional counterpart to the circle. draw some lines around it like that, but yeah, you just need one dimension for the sphere. You need the radius, because it's all points on the sphere are the same distance to that center r. And the volume, yeah, they are what they are. It's 4/3 pi r cubed for the volume, and then the surface area is 4 pi r squared. So if you got the radius, you just plug it in to those. Use the pi. Just follow pi. Now the one problem I'll show you here. Question? Oh, sorry. The one problem I'll show you on this one is, let's say we've got the volume of a sphere is (288 pi cubic inches). What is its diameter and surface area? And again, let's do this in terms of pi. We rounded. Okay. So yeah, this one is similar to one we talked about a couple minutes ago. I've got the volume is 288 pi. I know volume is 4/3 pi r cubed. Well, I can substitute the volume to be 288 pi. And let's see what we can do with that. So the deal is I've got to figure out the radius from that. All right, so I just plug in the 288 pi into the volume formula here. Now, however you want to, but one thing we can do here to figure out the radius is, see this 4/3, if I multiply by the reciprocal, or however, I said there's several ways I can do this, but if I multiply by the reciprocal of that 3/4, what that does is it cancels out the 4 and it cancels out the 3. It gets rid of that 4/3. So I have to do that on this side. Well, if you take 3/4, 3 divided by 4 times 288, I'm going to leave the pi in there for a second. So 3 divided by 4 times the 288, that gives you 216. So those two multiplied give you 216. Now, divide off the pi, you got 216 equals r cubed, right? Because the pi's are gone. Well, wouldn't r be the cube root of 216? Yeah. Instead of square root, I just cube root it, which, yeah, that cube root of that, what do you cube to get 216? That's 6. So the radius is 6, which means the diameter is 12 inches. And then the surface area is 4 pi times the radius squared. So 4 pi times 6 squared, they want it in terms of pi, so that'd be 36 times 4 is 144. So 36 times 4 is how that goes, 144. And that's inches squared. I want to show you that one, because I think I have one like that.
Can you leave this up? We're
Yes.
still